Okay, so I got some question. Can you explain the deformation tensor G? Okay, so I think this means this page. What is the page? 53. This is 54, 53. So there is a explanation about G. Yeah. So this is very simple. Actually, it's simple. So I can use whiteboard. Unfortunately, this they started putting ad here. Let me see. See here. I don't think we had this one before. Advertisement they started putting. So we have material space. This is x1, x large x, and material coordinate. Right? I'm sorry, material coordinate and spatial coordinate. Small x, small x1, small x2. Then you can just consider small segment like dx. This is vector, so you can say this is dx1, dx2, dx3, right? So here corresponding small segment you call small x. So this is also have dx1, dx2, dx3, right? So in this case, which is the one? So we use a small one. We take this one. Segment length in small spatial coordinate, right? So we consider this one. This one. So ds actually, okay, ds square is simple, right? D small x1 square, d small x2 square, and d small x3 square, right? Then we consider, for example, dx1. If we consider dx1, this one can be written as partial dx1 partial dx large x dx large x partial small x1 large x2 large x2 plus partial small x2 no 1 partial large x3 dx3. Then you can write this in simpler form, like dx1, dx alpha, dx alpha. Then this one can be also written as a simple form, like partial alpha x1 dx1 dx alpha. Yeah. So now this one can be anything. One can be 2 or 3, right? So we just write dxi instead of 1 to 3. We use I. This is like partial alpha xi dx alpha, right? Then you can go back to this part. This part, right? This part, how do we do this? This can be written as this. ds, sorry, ds square is dxi dxi. So this is exactly means the same thing. I is a summation. I is a summation. So this goes like this. This goes like this. This thing goes like this. dxi dxi, right? So then you use this one. Just one above. You use this one. So how do you get? Then you have to change alpha and beta. Partial alpha xi d large X alpha, partial beta xi d x beta. Yeah, so then you go like this. Partial alpha xi, partial beta xi d x alpha d x beta. Yeah, so this is like this. Partial xi, partial large x alpha, partial xi, partial large x beta, and d x alpha d x beta, right? So then this part is called g alpha beta. Is it clear? I think it's clear. So, and this one, this is called f alpha I think. Yeah. And this one, this is called f beta I. And you can see funny rule. I would say this is funny. You have two matrices like A and B, which has indices like A ij, B jk. So this matrix ik element can be written as A ij, so this is j, B jk. So this is a summation. Summation. Yeah. Sum. Okay, this is sum. And considering this rule, you can write this f alpha I, then this is like this. F transpose I beta. This one is F transpose I beta, right? So this is G. This is like F transpose alpha beta. This is like alpha beta, right? So that means G is exactly equal FF transpose. So you have this G equal FF transpose. That's it. So the important part, very important part is actually this one. See? Then this is the most important. The second important is this. Yeah. Then you can obtain G tensor easily. I can show you this one again. So this way. Okay, so I think it is clear. If you